that if you are given a matrix a basis, right? How do you represent a matrix in that basis? That is what I want to talk about. What does it mean for this question? Yeah, it means that I say, okay, represent something in the sigma z basis, which is 0 and 1, right? You have a matrix like sigma z, right? Or represent in the plus minus basis, which is the eigenvector of the sigma x. They have different representation. It's just like in vector, we already know, right? For vector, for example, for this vector 0, right? This one is just 1, 0 in the sigma z eigenstate eigenvector basis, right? Do you agree? But what is this in the sigma x eigenvector basis, right? If you remember all the equation or this fake diagram, this is 0, this is 1, this is plus, and this is minus. This is fake, but the result is correct. Yeah, so 0 is what? It's just equal to 1 over square root 2 of plus, minus, right? So how do you represent this vector in the plus minus basis? Say again. 1 by root 2, 1, and then 1. Very good, right? Because this is talking about I have one component of plus and I have one component of minus, right? Okay? You know this already. We talked about this earlier, right? But how about for the matrix, right? What is the easy way to write this? So here I'm going to give you the equation. If I give you given a basis, it is a set, right? So I write it in this way. It's a set of vector, and this is a basis. Given this basis, right? What is the matrix representation of, for example, I call it H, of an operator H, right? What is that? Okay, so the answer is the elements of H, Hij. Hij is the elements of H equals to IHJ. Okay, this means the ith row, jth column element of H. Is this okay? Do you understand what I'm talking about? Right, so let's review again. I know this is confusing, but you should, this class is to train you to be very familiar with this very confusing symbol. I is a cat, is the basis cat of the basis, right? That we are talking about. For example, it can be, if it's a 3D, it's x hat, y hat, z hat. If it is in the 1 qubit C2 system, it is what? What are the basis states of the 1 qubit? 0 and 1. If we use the 0, 1 as the basis. Or it can be plus minus if we use plus minus as the basis. So I have a matrix. This matrix has elements, right? How many elements does it have if I have an n-dimensional basis? n squared, n by n, right? So if it is a qubit, what is the size? If it's 1 qubit, what is the size? How many basis vector do you have for a qubit? 2, 0 and 1, right? So this is 2 by 2. They are basically saying, so let's just take a look. For example, maybe it's easier to make an example. The H might be sigma Z, right? So what is H00? What is sigma Z? Do you remember? Everyone forgot. Recall sigma Z equals to, what is that? 1, 0? Yes, 0, negative 1, right? So what is H00? 1, because it is the 0th row and 0th column, right? What is H01? 0, right? Okay, that is what it means. And what I'm telling you is that, for example, H01 is just equal to 0, H1. That is what we mean by this equation. If you want to represent any matrix, any operator in the matrix form of a basis, all you need to do just sandwich it with the basis vector. Okay, so I'm going to prove to you this is correct, right? The proof is just an exercise. I don't have many proof in the exam, but I would like you to appreciate what this is doing, okay? So let's look at this. H, which is just an operator, we still have not expressed it in anything yet, is equal to IHI. Do you agree? Yeah, what is I? Identity matrix, right? I can insert any I want, okay? Now, then I write this. See if you will be surprised or you feel confused. I say, this is equal to this. And I want you to tell me why I'm correct. Why I can write this. Anyone remember what is this equation? Which equation did I use? I think you used in your assignment one also. What is this? Again, you need to recall. What is this operation? Outer product. So it's a what? A matrix, right? Why the I equal to this one? I'm basically telling you that I is the outer product of all the basis vector and you sum them together. We learned this before. What is the keyword? Remember? Completeness. The completeness of the basis give us that if you do the sum of the outer products of all the basis vector, you get I. You need to memorize this. The grouping symbol, which one? Very good. Yeah. He said this is very unclear, right? So if I put this, would that be better? Yeah, that would be better, right? But, okay, no but. I agree with you. Let's do this, okay? Now, then because this is summation, I can take it out because I is not related to, I can take this out. Because the I is not related to J, J is not related to I. So there's no problem for me to take the whole thing out. And now I'm not going to group them anymore. Is this okay? I take this out, then I have this one, right? What is this one? I define this one as Oh, I don't define it yet, right? I have this whole thing. What is this? Is this a number, vector, matrix? A scalar. Scalar, very good. A scalar. Why? Because this is a vector. Multiplied by a matrix is still a vector. Then you do an inner product with the bra. Then it becomes a number, right? So this is a number, right? So I can take this to here. I can call this Hij. I just want to call it Hij. Let me call this Hij. Then this one becomes this. And because you just told me this is a number, I can move it to anywhere as I want. I decided to move it to the end, which is just a number. Is this okay? This is just a number. I can group them because of the associative property of all the bracket notation we have learned. Okay. Now what is this? Matrix, right? Because this is a vector, a cat times the bra, so it's the outer product, right? Now think about what is Ij. Think about that. I mean, write it in the column form. What is I? I just told you I is what? I is the basis vector, right? So in column form, how does it look like? Should be 0, 0 all the way to 1, which is the ith element, right? 0, right? How about j? J, I just jump a little bit. I do the bra version. What is that? Jth column. Yes, 1, 0. This is jth, right? Okay. So then what is I outer product of j? Just do the multiplication. What do I get? 0 times 0 becomes the first one. 0 times 0, everything is 0. Everything is 0. Everything is 0 until what? Where, huh? Good. Until you get a 1 here. And this is the this one is the Hij, right? The ith row and jth column, correct? So basically here what it is saying is that you multiply this outer product, you put the Hij into here. So you are adding the elements, the matrix together. Each matrix only have one non-zero element, and that non-zero element is the ith row and jth column. That is the meaning you add them together, right? Basically, this is saying that I am adding 1, 0, 0, right? Plus 0, 1, 0, 0, plus whatever, eventually 0, 0, 1, right? Not 1, I say the wrong thing, times H 0, 0, H 0, 0, no. What I'm saying is, let me finish this. I did not write it well. N minus 1, N minus 1. The whole thing. When you add them together, what is this? This is just H. H00 all the way to Hn. Maybe I don't write this just to save the space. What I'm trying to say is the H in D equals to H if the element is given by IHJ. And basically what I'm trying to say is that if I want to represent H in this basis, each of the elements is given by IHJ. Okay, this is a little bit messy. I will request you, any obvious question now? Anything not clear? For the given basis. They are the same basis, but they are different. They may be the same or different. That's why I give it I and J, different name. So it can be 0 to 1 or 0 to 1. It can be 0, 0, 0, 1, 1, 0, 1, 1 for 1 cubic case. I do want you to spend some time to understand what I'm talking about here, because this is related to some fundamental concept. But the minimum thing is, if I ask you to represent a matrix in a certain basis, how do you represent it? You use this equation. Okay? Let's do an example. Example is the best, right? For example, I have sigma x. What is sigma x again? Say again. 0, 1, 1, 0. Okay? Right? This is in what basis? Is in sigma z basis. Right? I mean, of course, remember, it means in the sigma z eigenvector basis, right? To be more specific, right? Because it's using 0 and 1, right? Now I want to represent it. How to represent it in the sigma x eigenvector basis, right? How do I represent it? Then what I need to do is to find out what are the eigenvector, right? The basis. Now the basis is what? Plus and minus. Right? I call, because this is just a name I call it, you can call it happy and sad, right? But for plus and minus, I want to represent them in the sigma z basis because I need this to do the operation. What is plus? Square root 0 plus 1, right? How about the minus? Do you remember what it is? Minus 1, because it's minus, right? And again, the fake 2D plane figure still give you the right equation, right? So now I want to ask, what is the sigma x, right, in the plus minus basis? Okay, then based on the equation we learned before, it must be equal to sigma x plus sigma x minus sigma x plus sigma x plus. Is this okay? Because this element is just like Hij. In this case, is sigma x. You can call it minus plus. Right? Because we have two, we want to represent in this plus minus basis. In plus minus basis, I only have two elements, plus and minus. Okay, just like I want, yeah. Thank you. Yeah, I said it wrong. Good point. There should be minus minus because this is the second basis, so it is minus minus. Very good. So how do we evaluate it? It's easy. Just do something. Let's just try. What is plus sigma x plus? Right? It applies to itself. Now, I'm going to use the sigma c basis to help me. First, I know this plus is 1 over square root 2. I already have the matrix, so this is 1, 1. And the sigma x matrix is 0, 1, 1, 0. This plus, I say the wrong thing, right? This is the bra, so it has to be what? Should be horizontal, should be a row. Okay, so what is this? Let's do it step by step, right? I want you to know everything. This is 0 times 1 plus 1 times 1. Is that okay? The first element. Anyone has problem with this? I know it's very simple, but you cannot make mistake. Second is 1 times 1 plus 0 times 1. Am I correct? So what is this? 1, 1 times 1, 1, right? So this is equal to 1 over 2, 1 times 1 plus 1 times 1, right? What is this? Huh? What is this? 1. It's a number. Is that correct? And should I expect to get a number? A scalar? Where is scalar? Where is sandwich, right? And this is the first element. 1. Okay? If you go back, I think it's in the assignment, right? You will find this is 0, this is 0, this is negative 1. So if you represent the sigma x in its eigenvector basis, you get diagonal matrix again, which makes sense. Because if you represent it in its eigenvector basis, it is diagonal, and this is what? Huh? When it's diagonal, what are these values? What do we call them? They are eigenvalues. Right, so this again proves what we were correct about that. When you first diagonalize the matrix, you get eigenvalues along the column. And it doesn't matter whether you measure in x or z direction, their eigenvalues are the same. The physics are the same because the universe is isotropic. So this is just an exercise, but the most important thing is do not just feel that I can do it and then you stop. Think about why, what we are doing. And particularly, when I'm doing this calculation, once I put something into a matrix form, I have chosen a basis to write it already. When I write this, which basis we are writing? We are using? Sigma z basis, 0, 1. Yeah, this is the 0 and 1 basis. We are using the sigma, we're using the 0 and 1 basis in this calculation, right? Because I dare to write 0, 1, 1, 0, then it means this is in the 0 and 1 basis, not plus minus 1. So yeah. This way here,
So that will be just 1,
1, 0. Yeah. If you say I want to write it in the sigma x basis, then this is 1, 0. This is 1, 0. But you don't know this because we're trying to find this. So you cannot do the calculation. Basis. Exactly. Everything has to be same basis, right? Very good. It's just like I have $5, you have 1,000 Japanese yen. You want to see who is richer, we need to convert to the same basis. Okay, or you see what is the total wealth we have, you want to do addition, convert to either Japanese yen or US dollar. Then you do the calculation. If this is in Japanese yen, this is in US dollar, no way, you get the wrong answer. Excellent. Okay, so we finished a lot of math. Now let's move